Notes 12-5, writing quadratic equations. We're going to be looking at the axis of symmetry and the vertex. And the date for these are 3/26. They're for Tuesday's class, 3/26. The axis of symmetry is a graph, has a symmetric vertical line. And the vertex is the minimum or maximum point which is also called the turning point. And a quadratic is read in the form y equals ax squared plus bx plus c. In order to find the axis of symmetry line, you are going to use x equals negative b over 2a. Therefore, the x coordinate of the vertex is the same as the axis of symmetry. So your first equation or your first example is y equals x squared minus 4x plus 1. Let's identify the values for a, b, and c. The value for a is 1. It's a coefficient of 1 in front of the x squared. The value for b is negative 4. It's the value in front of the x. And the value for c is positive 1. In order to find the axis of symmetry, you are going to use negative b over 2a. And now that's a negative 4, because our value for b is negative 4, over 2 times a, which is 1. This simplifies to a positive 4 over 2, which gives us an axis of symmetry of x equals 2. That means the axis of symmetry crosses the x-axis at positive 2. And that dotted line represents the axis of symmetry for this parabola. Now finding the vertex. You're going to use your equation, x squared minus 4x plus 1, and you're going to plug in the x value of 2. 2 squared minus 4 times 2 plus 1. So that gives me y equals 4 minus 8 plus 1, which is 4 minus 8 is negative 4, plus 1 is negative 3. And is this a minimum or maximum? Well, if I graphed this parabola, I would have a point here and a point here, and the turning point, or the vertex, I put my x, which is 2, and my y coordinate, which is negative 3, and my turning point is going to be right there. This point is a minimum value. And so my parabola looks like that. And I just found those other 2 points, the point here and here, by a table of values like we did before, the previous day, and just picked different values to put in for the x in order to get 2 more points for the parabola. I'm most concerned with the axis of symmetry and the vertex for these examples. In the second example, it shows me my new equation is a negative x squared, which means I know I'm going to have a maximum point because the graph is going to be upside down. And finding the axis of symmetry starts off with x. Again, x equals negative b over 2a. Always doing the same thing. So a, b, and c. C is 5. B is negative 2. A is a negative, but that's a negative 1. So we have negative put in my b, which is negative 2, and 2 times a, which is 2 times a negative 1. I get positive 2 over negative 2, which gives me an axis of symmetry of x equals negative 1. So this axis of symmetry crosses the x-axis at negative 1. And that's the middle of the quadratic. Now I'm going to use that and plug it into my quadratic to get my vertex. So I have y equals negative 1 squared minus 2 times negative 1 plus 5. So that gives me y equals negative 1 plus 2 plus 5. And so that gives me 1 plus 5, which is 6. So the vertex or the turning point is the x-coordinate, negative 1, and the y-coordinate, positive 6. So negative 1, positive 6 is up here. And if I just pick any other 2 random points and plug them into the quadratic, 1 comma 2 is another point, and negative 3 comma 2 is another point on the parabola. And so your parabola looks a little bit like that, and that's a maximum, which is negative 1 comma 6 is my maximum point. Moving on to question number 3, x squared minus 3, what is the axis of symmetry? My a value is 1, my b is 0 because there's no x term, and my c is negative 3. So x equals negative b over 2a, and a negative b, which would be a negative 0, is still just 0, and 2a would be 2 times 1. So I have x equals 0 for my axis of symmetry, and that means that it is a line that crosses the x-axis at 0. Looks just like that. And now I'm going to substitute 0 into my equation. So I have y equals 0 squared minus 3, which is y equals negative 3. And so the vertex is the x-coordinate 0, the y-coordinate negative 3, 0, negative 3 is right here. If I pick 2 other points in order to graph them, 2, 1 is a point on the parabola, and negative 2, 1 is a point on the parabola. And so our parabola looks a little like this, where we have a minimum at 0, negative 3. That's our lowest point on the graph. Y equals x squared plus 2x. We have a equals positive 1, b equals positive 2, c is 0 because there is no constant. There is no c term. What is the axis of symmetry? X equals negative b over 2a. So that's a negative 2 over 2 times 1, which gives me negative 2 over 2. So the axis of symmetry is negative 1. We're going to plug that into our equation, and we get y equals negative 1 squared plus 2 times negative 1, which gives me 1 minus 2, which is negative 1. So the vertex is negative 1, negative 1. And so I have an axis of symmetry crossing the x-axis at negative 1. And negative 1 is my minimum value. And I'm going to plot the point 1, positive 3, and negative 3, positive 3 to get the rest of my parabola. And here I have a minimum at negative 1, negative 1. Your last example, number 5, x squared minus 7x plus 10. We have an a of 1, a b of negative 7, a c of positive 10. So x equals negative b over 2a equals negative 7 over 2 times 1 which gives me positive 7 over 2. 7 over 2 is 3.5. So we are plotting this axis of symmetry in between 3 and 4 at 3.5. And now we're going to plug in 3.5, square it, multiply it by 7, and add 10. This is going to give me a y value of negative 2.25, which means I have a minimum value at the point 3.5, negative 2.25. And that is right around there on the graph. And my other 2 points are 2, 0, and 5, 0, to give me my parabola. And so here's my minimum point.